Hello and welcome to the Sketchlist 3D video guide. Sketchlist helps you brainstorm, plan, and execute your creative projects. This video demonstrates the preparation process and the practical use of the DFX machine board.
All right, so let's start by double-clicking the DXF. VCarve will automatically open a DXF as if it's a new VCarve file or an existing, VCarve file. All right, so VCarve has opened up into job setup screen here. So one of the interesting questions Guy asked was about two-sided machining, basically. So here, Guy, in VCarve, I can do single-sided or double-sided or even rotary. We don't need to worry about that. But if I had features on both sides of the panel, I can do it as a double-sided, and VCarve will actually can give me a ghosted image of both sides at the same time. But from a CNC standpoint, I can only mill one side at a time. So I would have to have some indexing feature for resetting to the other side to finish up the board. In general, in a production environment, I'm going to avoid double-sided machining like the plague unless I absolutely have to. So in this case, the job size is 48 by 96. This came off the optimizer, so it's giving me the full-size board. I'm going to cut that down because I've got a 18 by 24 machine, so that's what I'm going to do. I'm going to go 24 wide. I'm going to go 18 deep. All right, so that's my working zone there. I can zoom out. I'm going to get rid of all the waste boards here. All right, so before I do that, this is all part of the 4x8, but the white part is my actual machine bed because I'm using a ShopBot desktop in this case. Material surface is my 0 position. I'm going to start from the lower corner, so I'm going to leave that. I don't need an offset because we've already brought it in. And obviously, in this case, it's a little bit different. This is, I think, because of the way you did the grain, Dave. This one had the grain going vertical this way. So that's why it showed up here and not in the middle of the board like we saw when you did the layout. So now I'm going to hit OK on that. And I'm going to select this top board up here. And that came in as a square all by itself, which is nice. I'm going to delete that. This one also did, but before I delete it, let's go in. I just want to zoom in and see what we did get for a dimension here. Where's my measuring tool? Yeah, that's right at 1/8 of an inch in between pieces, which in this case, I think was what we wanted because of these. The optimizer, I think, was set for sawing when we did this. So I'm going to select that and get rid of it. All right. So now I have the board. There's our base. I'm not seeing a rabbit on here, Dave. I wonder if it stayed on the other side.
Maybe I messed up and put the rabbit on the right instead of the left.
All right. Well, I'm going to continue anyways, lay this out. And so the next part in VCarve, whenever you bring in a DXF file, you want to make sure that everything is connected. And so if I click on this, and this is actually quite good, by the way, the fact that this came in as a box, the fact that this is a separate box, that's not always what you get out of a DXF file. A lot of times when you translate a DXF from other places, you have to like individually compensate for these. So I'm going to select everything, and I'm going to come over here to join open vectors. And I actually have 10 closed vectors to start with and 10 closed vectors so I'm not joining anything. And if you look, I've got 8 holes here, a dado, and my outside cut. So minus the rabbit for whatever reason. But this came in as discrete elements, which is really, really nice because a lot of times with DXF files, there will be a line buried under another line, and you have to like find, you'll have open vectors that you don't know about, you can't see, and then you have to do detective work to find them. In this case, I didn't have to do that. So that's a really nice feature. Yes, sir.
For the other initiate people who aren't all familiar with what the problem is you just solved, can you just back up a little bit? Because I think we might have some
Okay,
newcomers to
yeah,
CNC.
nope. All right, let me try. Yeah, so here's the thing. A lot of time when you notice how when I click on this box, the outside profile, it's all four sides come in together, okay? That doesn't always happen when you bring things into VCarve, DXF files. A lot of times if I drew this in my DeltaCAD, for example, it would be made up of four individual lines. And they appear to touch. And if I zoom in real close to a corner, they appear to touch. But sometimes in the computer, they're either not quite touching, or maybe I misdrew it a little bit and the lines overlap by a tiny amount. So VCarve or any CAD/CAM program can't deal with all those individual lines that don't quite connect. They want discrete elements. So there's a feature here in the drawing side of VCarve here called Join Open Vectors. And what it does is when I select something, it'll tell me over here how many vectors are selected. In this case, there's one closed and no open vectors. But if I had some open vectors, like if this box wasn't connected already, and I selected all four sides, it would tell me 4 open vectors. And then I can say anything within a certain tolerance. In this case, I've got my computer set to 30 thousandths. Usually it starts lower than that. But anything within 30 thousandths, connect them together as if they're one unit, and they become a closed vector. And so all of these circles, if I do this and select them, I've selected 4. Circles usually do come in okay because you draw them as a single piece. But a lot of times, especially with architectural drawings and things that other people have created for you, there may be they may have had a line underneath here that they trimmed off, but they didn't trim the part that was under this line. And so when you select everything, suddenly there's an open vector there that you can't see. I've got all closed vectors. Where's the open one? You can't see it because it's buried. And so sometimes you have to kind of collect individual components. But in this case, Sketchlist did a really, really good job of bringing this in as discrete elements. It's especially difficult when you see these lines here are actually overlapping. So this line, which is the outside box, and then the lines that make up the rabbet for the deck, they're right here, they're on the same path. It's very rare that those will import separately. Usually I have to select one, deselect the other, and then join the various elements I want together, making sure that they're grouped the way I want them before I have to do anything else. So this was really easy, and almost too easy. I think we lost a little bit of educational material here. But it's really nice that these came in as discrete elements. So now I've got 4 sides that make up a rabbet here. I've got all the circles that make up my holes, and I've got the outside dimension as well. And so I don't have to do much else here. The only thing I'm going to do at this point is I don't want to be right on the edge of my board. I want some clamping room, and I don't want to use the factory edge. So I'm going to go ahead and move this board. Whoops. I could align it so it's centered, but I'm not going to do that. In this case, what I want to do is move this geometry by a certain amount. Now I can move it absolute, or I can move it relative. In this case, I want to move relative. Everything's lined up right to the edge of the board, the 0 point, but I want to shift it in by 1/2 inch in each direction, just so that I don't have to worry about like clamps or using the factory edge. So there, I've just shifted it over. You can see that's done. And the last thing I'm going to do here, in this case, it's not that big a deal, but I'm going to select all of these holes, and I'm going to group them together. Now watch what happens. Right now, it's a little hard to see, but they're dotted lines. But when I hit group, they all become solid lines, and I can select them or deselect them as a group. And so again, on this panel, it's a simple thing, but if I had the whole nest done with the entire board, grouping these as I go makes life a lot easier when I want to select them for processing. And they're the first thing I'm going to process, so we'll go ahead and move over. So now that we're done with all our drawing part, that's done on this side of the screen, I'm going to switch the toolpath command. And now that comes over to here. I'm going to move my zoom window. So on the toolpath on this side, and I can have both up at the same time, but I like to have as much visible space here at the machine as I can. These are my toolpath commands. So this is where I'm going to take this is right now is a 2D drawing. Okay. Dave established the depth of the rabbet and the depth of the holes, for example, when he laid it out, but none of that information is in the DXF. It's a 2D DXF. So now what I'm going to do is I'm going to select the holes and I'm going to do a pocket toolpath. And I'm doing pockets because with a router bit, I don't really want to drill straight in and straight out. Okay. I want to, in an ideal world, I'd start with a bit that's slightly smaller than the hole and let the bit interpolate so it swirls into it rather than trying to drill, because at the minimum speed my CNC can run, 9 or 10,000 RPM, whatever it is, that router bit is a terrible drill bit and it'll just burn. So I think in the DXF that I prepared for the video, I made sure that these holes were 0.28 or 0.26, just so that they're a little bit smaller than the router bit and I could work them out. With a tool changer machine, with an industrial machine, I would use a 3/16 bit, or I could have used a 3/16 for all of this, cutouts included, and that way I could do it. That way I can avoid a tool change if my machine doesn't have a tool changer. On an industrial machine, I'll use whatever tools I want because I have a tool changer. But in this case, I don't, so I'm going to use the same tool for everything. So in this case, I don't know, Dave, what size did you make these holes? Did you make them quarter inch? Yeah, so I'm going to go ahead and select a 3/16 router bit. So when I go into select, actually I have to remove first, sorry. It's a little bit different. This the newer version has some weird things, so I have to remove the existing router bit, and then I can hit select. So I'm going to choose a 3/16 router bit, and I'm going to up the feed rate just a little bit. I'll go to 80 on that because I can, and then I'm going to apply. Pass depth is 0.25, and I'm going for a 3 7/8, 3/8 hole. All right, so we'll select that. So now I've got my end mill, router bit, whatever you want to call it. And if I select that, it's going to have all the parameters that I just set that were here when I said select. But if I don't want that, like in this case, let's say I want to let it do the drilling all at once. So I can do 0.375 here. Under the edit command, I can actually edit this without changing the tool in my database, which is important. We don't want to be constantly changing the tools in the database. So by doing this, I just did that. But if I go back to select and select that 3/8 bit again, oops. Now I've got two of them, sorry. I'll get rid of one. But if I go back here, notice this says 0.25 still for the depth, even though I changed the other one to 0.375. So that's the difference between selecting a bit here and editing a bit here. When you edit, you're only changing it for this program. But if I change it here and hit apply, I'm changing it in the database itself. So that's something to keep in mind. And I think that this was the second one, so I'm going to remove it, and then I can edit this one and see if it's what I wanted. Yes, it is. We're good. So I've selected my bit. Now I can do my pocketing. Technically, we're pocketing, but it's a tiny little pocket, so I'm not going to worry too much about it. But I can do it with the offset, where it starts in the center and works its way out, or I can do it with a raster, going side to side. I'll show you this when I do the rabbit back here, or the dado, because you'll see it better in the toolpath. And then I can always climb cut or conventional cut. You know, with a router, with a hand router, I tend to conventional cut, although I know climb cutting is often better. You usually get less tear out. With the CNC, I primarily climb cut unless I've got a really good reason not to, because the CNC does not care. Now, the other thing is the next step is ramping. One of the primary mistakes that new users make with routers and CNCs is plunging the bit straight into the material. Now, again, we've got a tiny little hole here, so it's a little bit difficult to do, but just like with a plunge router in your hand, you're going to plunge down, and as you're going down to the depth, you're going to be moving. You want to do that with your CNC, because when you push the router bit straight down in, it's spinning in place and it is cutting as it goes down. But what inevitably happens is it's just rubbing on the wood, and friction is going to create heat, and it's going to burn up your bit. Nothing will kill a carbide bit faster than heat. Overheating a carbide bit will dull it way faster than you can ever do it by cutting with it. So we want to avoid the heat buildup. So in this case, we're going to do a ramp. And again, we'll talk about it a little more when we do the long bit. Because in this case, I'm going to make the ramp fairly long. No, actually, I don't have to. I told it to do a 375. So I usually make my ramps either the diameter of the bit or a little bit less. So we'll make it 0.25. And that way, what that means is when the bit comes down, it's going to stop above the material and then move a 1/4 of an inch as it drops the 3/8 that we're telling it to cut. It's going to ramp in. And even that small ramp keeps it from staying in one place and generating heat. It makes a tremendous difference in the life of your tooling. Now, the other thing is naming these. Every tool path I do, there's a default name that gets thrown in. In this case, we're making a pocket, so it's pocket 1. If we do another one, it'll be pocket 2. The problem is I want you to get into the habit of naming your tool paths. And the reason being, I'm calling it shelf holes because that's what we're making. The reason being that if you come back to this program 6 months from now, a year from now, you want to make the same cabinet again or whatever, not having these things named means that you've got to go into each tool path to figure out which one's which. And it's just a pain. Yes, there's only 3 tool paths that we're going to have here, 4 on the actual video that I shot yesterday. But just get into the habit of doing that. I've made some very complex programs that had 20 different tool paths in it, and it can get very confusing. And just get into the habit of doing that. You'll be much happier. Once we hit calculate, VCarve is going to figure out everything, and it immediately switches to your 3D view. So this is a 3D view. The red line is our rapid movements. So we're starting from 0 here in the corner. It's going to go do these holes, move over to there, and do these holes going this way. And if I zoom in, you can see the blue is the actual tool path of the bit going down and doing the cutting. I'm going to revert back to the flat. And here on my preview, it allows me to preview selected tool paths or all the tool paths. I can also reset. So I'm going to go ahead and hit this, and it's going to go ahead and slowly make those. That's because of the ramp that I put in, because it's actually spiraling down into the hole. If I change the ramp, it'll move a little faster. So now, maybe that was just my computer being slow. But you can see I called out yellow for the toolpath bottoms here. So that's why this is yellow. So it shows up, the holes show up a little better. The preview is really, really good because let's say for some reason when Dave offset these, they were offset from each other the wrong distance, or there was a shift or something. Something glaring like that I could see right now and fix it without having to find out by cutting. So the tool pathing situation or the preview is very, very valuable to you as a user. Now, it won't tell me if these holes are the right size or not. I mean, technically it's telling me, but I've got no way of seeing that here. But if they were cutting all the way through, I would see the blue background and I would know that's not correct. So there's a lot of information you can pick up this way. Now I'm going to get out of the 3D, back to the 2D. Now I'm going to select this pocket. And again, close that because we don't need it. So now I've selected these vectors. This is also going to be a pocket because I'm cutting the dado. I'm using a 3/16 bit. I'm going to need to go back and forth on it to clean it out. And I want it nice and smooth and even. So once again, it's a pocket. This time we're only going, what did you say, 1/8, Dave? 1/8 of an inch deep.
The depth was 1/4, I think.
Okay, we'll do 1/4. Same end mill. I could change, but if I had a tool changing machine, I would probably swap to the 1/4 or maybe even a 3/8 or a half here, because that's a 3/4 groove. And the bigger the bit, the less time it takes. But since I don't have a tool changer, I don't want to make two separate programs and have to change tools. It's faster just to let this do the work. So we're going to just keep that. Now here, I'm going to change to a raster just for grins here, because I want you to see how it works. I'm going to keep the 1/2 inch or the 1/4 inch ramp. I'll talk about pocket allowance in a minute, but again, this time I'm going to call this the deck data. So I've identified it. So, whatever language you want to use is fine. It's just that when I come back, if I come back a year from now, I want to recognize what I wrote. So I'm going to calculate that. Now, in this case, let me go back to, I'm going to do a edit toolpath. If you need to make changes, this is where we do it. Notice the blue lines here. I'm going to zoom in. So I told it to raster, and notice that the raster shows this little box on the right-hand side here shows it's going to go side to side. So literally, my tool is going zip, 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 all the way up that. Obviously, this would take a very long time to process. Now I can change the angle. So if I go to 90 here, and I calculate that again, now we're doing the same thing, but we're going up and down, up and down. This is going to be much, much faster. But if I come in and edit that again, and I switch to offset, again, the graphic here shows that with offset, we start in the middle and it just swirls its way out until it gets to the end. So if I calculate that one, it looks similar until we zoom in. So now it's going to start right here. It's going to make a cut up, then back. And the first cut is going to be the full width of the bit, but then it's going to be stepping over 40%, and it's going to step over and step over until it cuts the whole pocket out. So that's pretty much what we want, and we're going to leave that the way it is. So now I can preview that toolpath. And again, it's just going back and forth. So this even shows me the path that my tool will take. This is good information to have, because when you start your machine, you very well may want to say, and I'll talk about it, but what I like to do is tell the operators, think about where the head is going to go first. In this case, it should go from the lower corner, or 0, to the first circular hole. And keep that in mind as you start the machine, because if it starts going in a completely different direction than what you expect, you're anticipating it, you can hit the stop button or hit the pause before you damage your wood or possibly damage the machine or anything else. 99% of the time, you're going to look at it and go, oh yeah, that is what it was supposed to do. Anyway, so we've got that. So now I can close this again. Now, the final piece here is the outside cut. And again, one nice graphic. This time, we're not going to pocket, obviously. We don't want to cut that all out. We are going to use a profile toolpath. And anytime you're cutting something out, this is what you're going to use. Start depth is 0, because in this case, we're starting at the top. But if I were going to cut out a hole in the middle of a pocket I had already made, I might want to set the start depth to the bottom of the pocket, and that saves me a step. In this case, I'm going to go for 0.72 instead of 0.75. I need to hold this part inside my sheet. So I could either use tabs, or in this case, I'm going to do what we call an onion skin. I'm going to leave about a 32nd of an inch behind when I cut. I'm not going to cut all the way through. And that way I can take the sheet later, just run a flush trim bit around all the parts and clean them up. And it maintains my vacuum if I'm using a vacuum table. It depends on what you need to do. Tabs are nice, but usually with the onion skin, the sanding is easier and you get cleaner sides, that you don't have the bumps left behind by the tabs that you have to sand out. But again, if it's a cabinet and you're going to edge band it, kind of doesn't matter. It all depends on what you need to do. So in this case, we're going to go back and select our the same 3/8 inch bit. And this is going to make 3 passes because it's set to 0.25, but that's okay. And I can edit the passes if I want. So right now I'm getting 3 equal passes. So you'll notice instead of being 0.25, 0.5, and 0.75, it's 2, 4, 4, 8, 7, 2, because it divided them equally. But if I wanted to, I could set a final pass for, let's say, a 30-second and hit apply. Now I've got 4 passes, and that last one is just a little tiny pass at the bottom. So if I needed to do a cleanup, I could do that. There's a lot of things I could do. Here, I could make it 2 and have the last one do that, whatever you want to do. This is something that is a very powerful process for you. Again, if I'm cutting out a piece of plywood and I'm going to edge band it all the way around, I don't really care. The edges can be a little, they don't have to be perfect. But if I'm cutting hardwoods, I may do something different. So I'm going to leave it with 3 passes. Now here, machine vectors on the outside, the inside are on. So the machine only knows where the center of our bit is. And when I show you the toolpath, you'll notice that it's outside this perimeter. But if I wanted to cut out, if I wanted this, the outside is my keeper, and we were going to cut this as an opening, like a panel opening, I would cut to the inside. And you'll notice if I select that, it not only shifts the graphic to the inside, but it's going in the opposite direction because we're climb cutting. If I go for conventional cut. So I have control over everything. The third option is on the line. And I don't usually do this for closed vectors like boxes, but a lot of times I might draw, just straight lines. And if I need to cut them with a relief bit or a dovetail bit or a T-slot bit or something like that, I don't need to worry about drawing the whole profile. As long as the center of the bit follows that line, I'm good to go, and I don't have to mess around with a lot of extra drawing. But in this case, we're definitely doing the outside, and we're going to climb cut. I can do a separate last pass. So I can make 3 passes down and then make a 4th pass stepping over by a given amount that I accept or I select. And what that'll do is actually, it'll cut taking steps down so you're not overloading your machine, but that last pass is just going to shave the outside edge, which it's a little bit extra time, but it cleans up the edges and you don't have to sand them after the fact. Here's where we would add tabs to the toolpath. But again, I don't need to because I'm onion skinning. And then here we're back to, remember we talked about ramps. So once again, we're going to ramp in. The bit's going to come down and it's going to ramp in rather than just try to plunge straight into my material. I'm going to just do a straight, smooth ramp. I can do a zigzag, I can do a spiral. We're just going to do a straight, smooth ramp. And when you ramp, that extra 1/4 of an inch that we tell it to cut downward, it's not going to leave that material behind. It will automatically overcut. The software does that for you. Now, the other thing I want to do is I want to add a lead. I can ramp in right on my cut line, wherever the bit starts here. But again, it tends to mark off the wood. So in this case, I want to do a lead. And I can do straight line leads, but I prefer circular leads with a ramp. So now what's going to happen is the bit's going to start outside the profile. It's going to curve into the cut line as it drops down. It's going to make the cut all the way around. It's going to overlap, and then it'll lead out as well. And that gives me a really nice. All of the flexing of the bit and everything as we go into the wood is all outside the part I want to cut. The only thing you got to be careful of here is if we're nesting a bunch of stuff together, that lead takes some room, and you either have to have a wider gap between your parts, or if you want the maximum nesting, you don't use leads for that. But in this case, we're going to. All right, so now we're going to name our toolpath. We're going to call it cutout. And Dave, I'm not paying attention. I have my full screen up, so I can't see if anybody's asking questions on the chat. Just let me know. Okay, so we're going to calculate that as a cutout. Now, so here's my lead right here, my lead in right here. Let me bring that over. So it's a little hard to see, but the bit's going to start here, ramp in, cut all the way around, come out and ramp and lead out again. And you'll see that in just a second as we do the preview. So you can see that little curl right there. And it's going to come around. Notice how it overlaps for the second part of the curl. So there's no leftover material. It defaults to, I think, a 30,000ths overlap, but I can make it an inch if I want to. So again, it's yellow because I didn't cut all the way through. If I had cut all the way through, it would be the same blue as the background. But notice here's my lead in, lead out. And I can change that, the position of the start. I can change the size of the lead-ins, lead-outs, whatever I want to do. So that's basically my cabinet side. This one doesn't have the rabbit at the bottom, but that's okay. The video that I took yesterday does, or day before yesterday. So now that we've got our tool paths, they're all the same bit, so I can select them together. And now I want to save the tool path here. So I've got my shelf holes, and it's all three are the same bit. If they weren't, this would warn me. There's my machine, but honestly, if you look at the post processors, no, it doesn't do it like it used to. It used to have just be able to look at the whole list. But pardon me, let's do that real quick. I just want to show you. Oh, wait a minute. Let's see, right there, add post processor. Let's see, add right here. Okay, so this is a list of all the post processors that are available in VCarve. So there aren't very many machines made that aren't in here somewhere. Those of you with the Origin, I think you're going to find that that is not in here, but you're not going to program from here. It has its own software. But my ShopBot is in here. The VCarve is in here. The Next Wave Sharks are in here, and all of the major brands as well. There's hundreds of them. So in my case, I'm going to go to the ShopBot, but again, CNC Shark. So there's several options for the CNC Shark. This is the rotary. I would use the USB arcs metric or arcs inch. And then if I go down to the S's, to ShopBot, so I can, and the nice thing is I can use the ShopBot in inches or in metric for those of the, so for our friends overseas. But you know, that's the one I would choose. And in fact, I have it selected here. Cancel. So I can hit Save Toolpaths, and then it comes up. This is the boring that I create, the boring pattern I created from yesterday. We'll just call this one Ralph DXF. And so now that's ready to go with my machine. And I left the dust collector off. Normally I would have it on, but I left it off so you guys could see what the machine's doing. Now in this case, it's really hard to see. You can see just a little bit of smoke there. I'm using a 1/4 inch bit, and I made the holes 0.26. So it is technically flexing a little bit as it goes into the hole, but I really should have used a smaller tool. Now, on big industrial machines, they often have drill bits that are actually attached, and they are moving slow enough to drill clean holes without burning. But again, a 3/16 bit here would do a much better job. But there we go. That's our holes. Very quick and easy. Now watch as this goes down. You're going to see it ramp. There's the ramp. So it made a little zigzag to get down to full depth without just plunging in. That's going to save you a lot of wear and tear on your bits. It's going down the center now, and then it's going to shift over. And in this case, I believe I've got this set. This bit is cutting at 100 inches a minute on the ShopBot, which is pretty nice for a benchtop machine. Although, to be honest, if I were on a full-size industrial machine, this should be running at closer to 600 inches a minute. The weight of the machine and the rigidity of it really does make a difference. And you'll see a little bit of shaking here. That's not my machine. That's actually the stand it's standing on. I've got it on a router table stand at the moment.
Ralph, it looks like you had the cleaning people come in and do up the shop for the video.
No, this is just a very careful selection of where I put the machine and the camera. Believe me, it's not clean. But yeah, so I've got the bit set to step over 40% of its own dimension as you do these cutouts, and that's what it just did. There's that ramping maneuver again. Now I'm cutting the rabbit on the back. This is 3/8 deep, but I think I may have done it all in one pass because I was feeling aggressive. In general, I recommend that you set your depth of cut for a bit to be the diameter of the bit or maybe a little less. But once you get comfortable with your machine and the bits you're using, you can get more aggressive about it. But you kind of need to learn I did it in 2 passes, obviously. You need to learn the rules before you can break them. So starting out slow and working up works pretty good. And just in general, for a 1/4 inch bit, I'm going to set a 60. Yeah, I turn the RPM of the machine up a little bit because this next cutout is going to be pretty aggressive. But generally on a 1/4 inch bit, I'll do a 1/4 inch depth of cut, and I'll do a feed rate of around 60 to start. And if that works, then I might boost it up a little bit more until I start hearing the machine struggling. But here, I've cut the feed speed down to about 80, and it's moving right along, but it's cutting pretty nicely. If I had the dust collector on, most of that dust would go away. So it takes 3 passes to go around, but I did shoot a little bit of a close-up of the lead in and lead out. So I want to show you that. But I've been doing this for, I don't know, 25 years. I still love watching these things work.
I do too. I was thinking the same thing.
Okay, here's the close-up. So you can see there's that lead in and lead out. So it comes in, it ramps down, and then so that lead in means that I get a very, very clean edge there. There's not going to be any, because all tools will flex as they enter the wood. There's they're not completely stiff or else they'd be brittle. They have to flex a little bit, and not enough to really matter, but it will leave a mark behind if you don't. So by doing the lead in, the marks are left in the waste, not up against my board. And then after the cutout finished, it's going to go all the way back to the lead, and then it'll head back to 0. So after vacuuming everything up, this is what it looks like. So you can see I've got both the rabbit and the dado here. I've got the holes. I got the thing cut out. It came out pretty nice.
Win more bids, spot the mistakes early, and pull advanced reports with Sketchlist, a complete 3D design software for all your wood project needs.